In this video, I'm going to talk about how to find the volume using cross sections. So here we're given a circular base of x squared plus y squared equals 4, which you can see pictured below. We're asked to find the cross section using squares. So from that information, I'm immediately going to write down the area of a square, which is the side squared. And then we're told that we're going perpendicular to the x-axis. And this tells us what we're taking the integral with respect to. So since we're going over the x-axis, we're going with respect to x. We'll be using dx. And we're going to try and find the volume of the resulting solid. So if I draw in what would be the length of my square, or the side of my square, I'm coming from end to end of the circle. So what we want to find is the length of this whole line, but we can most definitely find the length from our function to our center line here. So if we take our equation, which is x squared plus y squared, equals 4, and we solve for y, we're going to get y squared is equal to x squared minus 4, or sorry, 4 minus x squared. Let me fix that. And then we're going to take the square root. So we get plus or minus 4 minus x squared, which means the distance from our circle, the top part of the circle, to the center is the square root of 4 minus x squared. So that's just from the top of the circle to the center. From the bottom of the circle to the center also be the same distance. So to get the full distance, we add them together. So our side length is equal to 2 times the square root of 4 minus x squared. So I'm going to plug that into my area formula. So I'm going to have 2 times the square root of 4 minus x squared, the whole thing squared. And I'm going to simplify that. So we're going to get 4 times 4 minus x squared. And then distribute my 4. So 16 minus 4x squared is my area. The last step here is to find the volume. So to find the volume, we're going to take the integral from a to b, which are going to be our upper and lower limits for our x values on our graph. And then we're going to take the volume of the area of a square with respect to x. Okay, so we're going to have our upper and lower limits. We've got -2 as our smallest x value and 2 as our highest. So we're going from -2 to 2. And then we're plugging in our area. So 16 minus 4x squared dx. And at this point, you guys can type your value into your calculator to get your final answer. I'm going to put it in fraction form, so you just got to hit second frac, or it's math frac, I apologize, on your calculator to get the fraction. And we'll find that the volume is equal to 128 over 3. For our second example, we've still got that same circular base, but this time our cross sections are in isosceles triangles. So an area of a triangle is 1/2 base times height. And we're doing perpendicular to the x-axis, which is dx. And we're asked to determine the volume of the solid. They also tell us that the altitude is going to be equal to its base. So really, we've just got b squared here, right? And our formula, since they're equal. All right, so here's our circle. And remember, to get our base of our triangle, we're going from circle to circle here. So this length is the piece we need to find. And remember from the last problem that we found when we solved for y, that y was equal to plus or minus the square root of 4 minus x squared, because it's the same equation. So from here to here is the square root of 4 minus x squared. And then again, from here to here is also that square root of 4 minus x squared. So the full base would be 2 times that. So our base value is 2 times the square root of 4 minus x squared. And we're going to plug that into our formula. So area is equal to 1/2 times 2 square root of 4 minus x squared squared. So that gives us 4 is 1/2 times 4 times 4 minus x squared, or 2 times 4 minus x squared, which gives us, distribute that to 8 minus 2x squared. So now that we have that, we can create our volume formula. So our volume is going to be the integral from A to B of the area of a triangle. So our A and B, again, are our lowest x and our highest x value, which are -2 and 2. And we're plugging in 8 minus 2x squared dx. And again, you're going to type this straight into your calculator. Okay, remember Math 9 on your calculator to plug in your upper and lower limits. And I'm going to put my answer in fractional form. So I'm going to have 64 over 3. We are still using the same circular base as the last two problems. So again, that means that y is equal to the positive and negative version of 4 minus x squared. So this time we've got the cross sections of an isosceles right triangle, which is a 45, 45, 90. So I know the area formula that I'm going to need is 1/2 base times height. We know that we're perpendicular to the x-axis, so we're doing dx, and we're going to determine the volume. They're letting us know that the hypotenuse of the 45, 45, 90 triangle is what is on our xy plane. So what that means is that the base of the triangle is going to be this piece, which we know from those other two problems that we solved that that is 2 times the square root of 4 minus x squared. Now this is a right triangle, so we have a right angle here, and to find the altitude, we're going to drop the altitude right down the middle, which actually creates another right angle here. And when we do that, we've split this in half, which means that this side length is just the square root of 4 minus x squared. So a property of 45, 45, 90 triangles, which this little triangle that we just created is also a 45, 45, 90, is that the legs of the triangle are going to be congruent. So if this leg is 4 square root of the square root of 4 minus x squared, then this leg of our little triangle would also be 4 minus x squared, which is the height of the bigger triangle. So now we've got the height and we've got our base. So I'm going to come up here and I'm going to write those out. We know that the base is 2 times the square root of 4 minus x squared. We know the height is just the square root of 4 minus x squared. And then we're going to plug them in. So we get 1/2 of 2 times 4 minus x squared. And then we're multiplying that by the square root of 4 minus x squared. So we've got 1/2 times 2, which cancels. And then the square root of 4 minus x squared times itself. So it just pops out. So we got 4 minus x squared. Now we're going to create that formula for our volume. So volume is going to be the integral from A to B of the area of our triangle So our A and B are still -2 to 2. We're plugging in our formula of 4 minus x squared dx. And then we're going to type this equation into our calculators to get our final answer of 32/3. For example 4, we're switching the base of our shape. It's now a parabolic base. So we've got y equals x squared. And it's bounded by the line y equals 9. So that line is not drawn in my picture, so I'm actually going to draw it in here. Okay, and then we're doing semicircles. So that's going to be my area formula. Area equals 1/2 the area, which is r squared, perpendicular to the y-axis. So now we're doing dy, so we're with respect to y. Okay, so that means our diameter is coming from here all the way over to here. So we've got to find this equation for the center, or for the radius, which is coming from the y-axis out to our y equals x squared. So we are solving with respect to y, so I'm actually going to take that equation we had, y equals x squared, and I'm going to solve for x. So I'm going to get plus or x equals plus or minus the square root of y. So this equation here is the square root of y, which means that we are getting, for this distance, which is our radius, we are going from the square root of y to 0. So really the square root of y minus 0 is just the square root of y. So we don't need a diameter, we just need the radius. So our radius is the square root of y, and we're going to plug it into our formula. So area is equal to 1/2 pi times the square root of y squared. So the square root of y squared gives us just y. And I'm going to write this 1/2 pi as pi over 2. So pi over 2y is our equation. And now we plug it in to our volume. So we've got volume equals the integral. I'm going to use c and d this time because we're looking for y values of the area of the semicircle. So my y values, my smallest y values down here, and it's 0. And we're only going up to this line y equals 9. So our limits will be from 0 to 9. And then we'll plug in our equation, pi over 2y dy. And when we plug this into the calculator, now I did not type pi into my calculator, so my answer could be a nice fraction. You're going to get 81/4, and then we would just stick pi next to our answer. Again, I did not type that pi into the calculator in order to do that. I just typed 1/2 y and then put pi on top with my numerator. For example number 5, we've still got that parabolic base and the y equals 9 lines. I'm going to draw that back in here. This time we're using an isosceles right triangle, which is that 45, 45, 90 triangle. The area is still 1/2 base times height for a triangle. And we're doing with respect to y because we've got y-axis here. And remember, we've already solved this for x in that last problem. So x is equal to plus or minus the square root of y. And again, that came from our original equation, y equals x squared. So when we're down here, we're looking for the base of our triangle. The base of our triangle is coming from this line here. I could have drawn it up here as well. So our distance from here to here is that square root of y, and then we know the distance from here to here is the square root of y. So our total distance for our base is 2 square root of y. So I'm going to come down to my triangle, and I'm going to draw out my right triangle. I need to find my altitude there. We're going to pretend that was a beautifully straight line. And when we draw that altitude down, we've cut the triangle in half, which means that this base of this triangle would be the square root of y. Now this mini triangle we just created is now another 45, 45, 90 triangle, which means that its height would also be the same as the base that it had here. So we find that the height is the square root of y. So I've got both of my pieces. My base was 2 square root of y, and my height was just the square root of y. And I'm going to plug that in to my area equation. So I've got 1/2 times 2 square root of y times the square root of y, which gives us 1/2 and 2 canceling. The square root of y times the square root of y is y. So our area formula is just y. So now for volume, we're going to go from C to D. And we're using the area of the triangle. And C and D are coming from our lower y value to our upper y value, which are 0 and 9. And then we're plugging in y. Now this one's pretty quick to do by hand, so I'm going to do this one by hand. We're going to have the volume is equal to 1/2 y squared, evaluated from 0 to 9. And when I plug 0 in there, right, I just get 0. So we really just got to plug in 9. So we've got 9 squared, which is 81 over 2, minus 0, which is just 81 over 2 for our final answer there. For example 6, we've got still that parabolic cross section, and y equals 9 is drawn in. And we're doing semicircles, but this time about the x-axis, so dx. So my area is going to equal 1/2 pi times the radius squared. So let's see what we can get for our radius. So if I'm looking at my picture, to get my radius going from top to bottom, I'm going from that line y equals 9 down to 0. So that's actually the diameter of the circle. It's from 9 minus our function, right? If I drew it out here, we're touching this function, which is x squared. So just like when we were finding the areas between the curves, we're doing top minus the bottom. Now that gave us the diameter, and we want the radius. So to get the radius, we just take our diameter and we divide it by 2. So now that I've got the piece that I need, I'm going to plug it into the area formula. So area is equal to 1/2 times pi times 9 minus x squared over 2 squared. I've got my area formula. Now I'm going to fill out my volume. So volume is equal to the integral from a to b of the area of a semicircle dx. So we find these upper and lower limits. Remember, we're ending at y equals 9. So if you need to solve that by hand, you can say x squared is equal to 9, which gives us x being positive or negative 3. But it's those intersections there. Is that what we're looking for upper and lower limits? So we're going to have negative 3 to 3. I'm going to write this as pi over 2. And then 9 minus x squared over 2 squared dx, which is not pretty. So again, I'm going to say type that into your calculator. But don't type pi in. I'm going to put my answer in terms of pi. And I'm going to get 162 pi over 5. For example 7, we've got the function y equals x, which is in red. And then we've got the function, and then we have y squared equals 4x, which I'm going to put in green. It's this curve here. And we're doing rectangles with a length that is perpendicular to the x-axis. So dx, we're doing in terms of x. And then the width is half of the length. Okay, so our area formula is going to be length times width. And they told us the width is half the length. So we can substitute for W 1/2 times the length, which means we've got L times L, which gives us 1/2 of L squared. We just got to figure out what L is. So remember again, when finding the area between the curves, we did top minus bottom. So we're going to do the top function minus the bottom function. But the only problem we have right now is this top function is right now with respect, it's not really with respect to anything, right? We need it to be with respect to x, so we need to solve for y. So we're going to get y is equal to plus or minus the square root of 4x. And because this piece is the positive side, this is just 4x underneath our radical there. So our length is going to equal the square root of 4x. And then we're coming down and we're hitting this line here, which is y equals x. So minus x will be our length. So we're going to plug that into our formula. We've got 1/2 times the square root of 4x minus x squared. Then we're going to plug this in to our volume formula. And we're doing with respect to x, so we've got 0 and 4. So we're going from 0 to 4 of 1/2 times the square root of 4x minus x squared dx. And we'll find that our volume is equal to 1.067. For this last example, there's a lot of calculator tricks that I'm not going to put on this video. So if you need to see those calculator tricks, please make sure you see me in class. So we've got the cross sections of the region y equals negative 2x squared plus 3, which is that blue function. And then y equals x sine of x, which is the red function. And the diameters are going to be for the circle. So we've got area is equal to pi r squared. And we're being perpendicular to the x-axis, which means we're doing with respect to x. So if I'm going with respect to x, I'm going from top to bottom, which is going to be our blue function minus our red function. So our r is equal to negative 2x squared plus 3 minus our red function, which is x sine of x. I take that back. That is not the radius. That is the diameter because it is a circle. And to get the radius, we're going to take half of that. So I'm going to take that whole thing and I'm going to divide it by 2. Now that I've got my radius, I'll stick it into my formula. So I'm going to have area is equal to pi times negative 2x squared plus 3 minus x sine of x over 2 squared. Now we're going to do our volume formula. So volume is equal to the integral from. Now these intersection points are the points you're going to need to find and store in your calculator. When I did it in class, I stored it as an A and a B in my calculator. I'm going to show you what the rounded answers would be on this video. But again, I want you to know how to store them. So if you need that help, please come see me in class. If we rounded, we would have negative 1.029 and positive 1.029. The negative should go on the bottom. And then I'm going to plug in my area. So pi parentheses negative 2x squared plus 3 minus x sine of x over 2 squared. And then there's a dx in there, which I'm not going to fit on my screen. And we would type that into our calculators. Now, I also showed in class how to, since we've already have them graphed, how to make that simpler when typing it in. So again, if you need to see that, please make sure you ask in class. And our final answer ended up being 7 point. I don't have that value written down, but it's 7.62 something, I believe. 7 point something. Give me a second, I'll type it in and I'll let you know. It was 7.632.